Part A. What is the initial acceleration, magnitude, and direction produced by the resistant force? Okay, so we're going to use F equals ma. And since we already are given the force, which is equal to negative kV, we're going to use that. And then we're going to set these two equal to each other. So ma equals negative kV. And then we're going to solve it with respect to a naught. So we're just going to, so ma naught is equal to negative kV naught. And then just simply solve for a naught. So then a naught equals negative kV naught over m. And that's part A. For part B, we are asked to derive an equation for the object's velocity as a function of time t, and sketch this function on the axis below. Let a velocity directed to the right be considered positive. Okay, so the derivative of velocity is acceleration, so dv over dt equals acceleration. So we're going to use our equation from part A, and we're going to say, therefore, dv over dt equals negative kv naught over m. And then we are going to separate the variables and integrate. So we're not gonna do v naught stuff. We're just gonna say v. So dv over v is equal to negative k over m dt. Then we're gonna integrate, and we're gonna get ln of v equals negative k over mt plus c. And then we are going to solve for, then we're going to use the initial condition, which is that at time t equals 0, v equals v naught. So when we're going to plug v naught in 0 into here, so therefore ln of v naught equals negative k over m times 0 plus c. Therefore, c equals ln of v naught. So then the equation becomes ln of v equals negative k over m t plus ln of v naught. And now we are going to solve for v. So we're going to take all this to the e power, and we're going to get v equals e to the negative k over mt plus ln of v naught. But this, eventually, you can move this out to the front, and you get v equals v naught e to the negative k over mt. And that is part B. But then the graph is gonna look. It's gonna start at v naught at t equals 0, and it's just gonna decrease to 0, because it is a negative exponential function. Alright, on to part C. Part C asks us, derive an equation for the distance of the object as a function of time t, and sketch this function on the axis below. Alright, well, the derivative of position is velocity, so we're going to use v equals dx over dt. And then dx over dt, as we solved from part B, equals v naught e to the negative k over mt. Now we're going to separate the variables and integrate again. So dx is equal to v naught e to the negative k over mt dt. And then we're just going to integrate, and we're going to get that x is equal to v naught times negative m over k e to the negative k t over m plus c. And then we're going to use the initial condition that at time equals 0, x equals 0. So therefore 0 equals v naught times m over negative m over k times e to the negative k times 0 over m plus c. Well, this all right here goes to 1, and therefore 0 equals, or C equals V naught times M over K. If you move this over. So now the equation becomes X equals V naught M over K e to the negative KT over M plus MV naught over over K. Okay. So now, putting it all together, we get that X equals V. Just kidding, we just put it all together. What am I saying? Okay, now the graph. Since this is a exponential function, it is going to start at 0, 0, and it's going to slope up. Since force is negative, acceleration is negative, so the graph is concave down. But since velocity is positive, the slope is positive. So the graph approaches some asymptotal value, which we haven't solved for, but we know that it approaches some value. Okay, now part B. So determine the distance the object travels from time t equals 0 to t equals infinity. So we're going to take the limit as t approaches infinity of the equation m v naught over k times 1 minus e to the negative k over kt over m. So this here, since this is negative, as t gets really big, this is going to go away to 1. No, I mean 0. And then it's just going to go to mv naught over k, because this goes away. So therefore, x equals mv naught over k. Now it is the distance that it will travel as time approaches infinity.